So the subject in tonight's video is going to be solving exponential equations, and we'll see in just a moment what we mean by exponential equations. And again, I'll say that in general our strategy will be to get the same base on each side of the equation and then set our exponents equal to each other. This will make a lot of sense once we get into an example, so we'll dive right in. So here we have our equations. They're exponential equations because we've got our variables as exponents. And as I said, we're going to try to get the same base on each side. So right now the base on one side is 8, the base on the other side is 2, and we'd really like to get these to be the same. The way we're going to look at doing that is see, is one of these a power of the other? Is 8 a power of 2 or is 2 a power of 8? That's the simplest example, and in this case we're lucky that 8 is indeed a power of 2. 8 is equal to 2 cubed. So what I'm able to do now is I'm going to say, well, over here I had an 8, but 8 is the same thing as 2 cubed. So instead of 8, I'm going to write 2 cubed and rewrite the equation. So I have 2 cubed again instead of my 8. So 8 to the x becomes 2 cubed to the x. The other side's going to stay the same, 2 to the x plus 6. And using my laws of exponents on the left-hand side, I get 2 to the 3x is equal to 2 to the x plus 6. Now, the only way that 2 raised to one power can be equal to 2 raised to another power is if those two powers are in fact the same. So it must be true that 3x and x plus 6 are the same, and we use equals to represent the same, so we can write 3x must be equal to x plus 6, which means that 2x is equal to 6, which means that x is equal to 3. So in general, once I get the same base on each side of these equations, they tend to become fairly straightforward to deal with. Let's look at another example. So in this equation, our bases are 1/2 and 4. And it is true that I could write 4 as a power of 1/2 or 1/2 as a power of 4, but in a case like this it's actually going to be easier for us to try to write both of these numbers as a power of a common base. The easiest one to work with in this case is going to be 2, because 2 to the negative 1 is 1/2, and 2 squared is 4. So I can take 2 squared and put that in the place of 4. I can take 2 to the negative first and put that in place of 1/2. And we'll get an equation that's going to be a lot easier to work with. So we'll get 2 to the negative first to the x minus 4 power is going to be equal to 2 squared to the 2x power. And when we simplify our exponents, we'll get 2 to the negative x plus 4 is equal to 2 to the 4x. And as last time now, I can set these exponents equal. Negative x plus 4 is equal to 4x. Adding x to each side, I'll get that 4 is equal to 5x. And x is equal to 4/5. Now, in theory, I could make these problems a lot more challenging by making it so that you've got something much more difficult to deal with when you get to this step here, but for the time being, we're really not going to go there. Now, here's an example because not everything's perfect. It's not easy to write 5 and 200 as powers of the same number. So we're going to look at two different approaches for how to deal with this problem. The first approach that I'm going to do on the left here is to take this problem and rewrite it as a logarithm. So we'll have that log base 5 of 200 is equal to x minus 2. And if I wanted to solve for x, I can add 2 to each side. So I'll get that x is equal to log base 5 of 200 plus 2. And this is an exact answer. This is an answer to the problem. But generally from here I'm going to want to go ahead and use a calculator to get an approximate value for this solution. So I would need to use my change of base formula at this point and write that x is equal to log of 200 divided by log of 5, and then add 2 to that. And when I type that into my calculator, I get that x is approximately equal to 5.292. So that's one way to approach this, but just as I can add, subtract, multiply, or divide on each side of an equation without changing its solutions, I can take the logarithm of each side. So if I take the logarithm of each side of this equation, I'll get log of 5 to the x minus 2 is equal to log of 200. And using my power property of logarithms, I can take this exponent here, x minus 2, and bring it down in front, so I'll get x minus 2 times log 5 is equal to log of 200. Hopefully at this point you can see it's about to look similar to what we had before. Divide by log 5 on each side, so x minus 2 is equal to log 200 over log 5, and I'll add 2, x is equal to log 200 over log 5 plus 2, just like we had on the other side. So there are two ways you can approach these kinds of problems. So please prepare these 3 problems for class. In each of these problems, please solve for x. In the second problem, please use a calculator to give an approximate answer for your solution. See you tomorrow.